Hi everyone, this is Arfeen, and today we are going to calculate risk adjusted performance measures. So let's start. Again, we are going to import libraries, import pandas as PD, import numpy as np, import pandas underscore data reader as web from beautiful oops, come on, from beautiful table import beautiful table, and from scipy import stats. I guess that's it. Let's run this. Now we need to define the function, call it RAPM, which is risk adjusted performance measures. Again, we need stocks, we need benchmark, we need start date, and we need end date. Okay, so first we need to define a data frame. So data is equal to pd dot data frame. Similarly, we need to have a benchmark. Bench is equal to data frame. Okay, so let's download data. Data is equal to web dot data reader stocks. So we need to make sure that we are putting the same name what we are putting here. So it's stocks data source Yahoo. Start is equal to start date and is equal to end date, and then we are going to use adjusted closing price. Similarly, for the benchmark bench, we need to do the same thing, web dot data reader. Here we will put benchmark data source, same Yahoo. Start is equal to start date and is equal to end date, and we are going to use adjusted closing price of index. Okay, so now we need to do one more thing here. We need to define table is equal to beautiful table. Why I'm doing this, basically I want to have a result in a proper display in a proper manner instead of like displaying it in a haphazard way, so which I will show you in a while. So for that I'm doing this. So table is equal to beautiful table, and then table dot columns. Okay, it's not here. Yeah, because I didn't run it. Dot header is equal to. Okay, so this is something I'm going to keep it blank right now. I'll show you what I need to put as a header, and then table dot set underscore style under bracket beautiful table dot. Okay, so we have all this suggestion, which I will show you later. So let's say box. This is something we will again discuss in a while. Okay, so let's put the loop. So for I and stocks, yes, so for I and stocks, what we need to do, we need to calculate return. So here I'm going to do one thing. First, calculation of daily return. So what we have data daily underscore return score plus I is equal to data I dot percentage change. Okay, it's not reading, I don't know why. Similarly, daily return, let's put stocks and benchmark. So I'm going to do it simultaneously at once. So bench daily return is equal to bench dot percentage change. Okay, now we need to calculate. Okay, what are the information we need to calculate? Let me put it here. So we are going to calculate return. Just for the sake of presentation, I'm calculating return here. I'm calculating, let's say, standard deviation. I'm calculating beta. I'm calculating tracking error. Sharpe ratio. Sortino ratio. Treynor ratio. And information ratio. Also, we need to calculate standard deviation and downside deviation here. Deviation. Yes, this spelling is wrong. So we are going to calculate all this thing. Okay, so let me. Okay, so we are going to calculate return, standard deviation, downside deviation, beta, tracking error, Sharpe ratio, Sortino ratio, Treynor ratio, and information ratio. So let's start. Okay, so I have calculated return of a stock and it's a daily return. Now I'm going to calculate calculation of cumulative return. So I'll just copy it and then paste it here. Okay, so stock return underscore I is equal to NP dot product. So why I'm doing this, you can find it in my previous video. That's why I am putting np.return, np.product daily underscore return score plus I plus 1 minus 1. So, okay, similarly, we need benchmark return as well. So it will be np.product bench daily return plus 1 minus 1. Now I'm going to calculation of down standard deviation and downside deviation. So std underscore I is equal to, let's copy this whole, dot std dot, sorry, multiply it with np dot sqrt of 252. So we are analyzing it, and then we need to calculate downside deviation. For that, I'm going to create a series of downside underscore plus I, and then data. So it's already copied here. So I will do this less than 0. Again, I need to filter this. So what I will do, so why I'm doing this, you can again find it in my video related to Sortino ratio. So you will find the downside deviation calculation of Sortino ratio, where I have explained why I am putting this daily return separately again after calculating this or filtering this data, which is less than 0. So, okay, now we have calculated our downside deviation. Basically, we have filtered it. Okay, so now all we need to do is we need to calculate downside deviation, which will be equal to, so we have this available already. Let's copy this, paste it here, std, and then multiply np dot square root of 252 days. So, and we are analyzing the downside deviation as well. And we can put some gap here. Okay, so it will look more good. Okay, so yeah, here as well. Now we need to calculate beta. So for beta, again, you can find it in our previous video, how I was calculating beta. So beta of I is equal to stats dot linear regression. Let's check what we need to put there, X and Y. So again, our X will be the daily return of stock dot drop NA, Again, you can find my previous video related to Treynor ratio where I have calculated beta and I have explained why I'm putting drop. Okay, so that's good. I noticed this here. So it's not copied properly. I need to copy it, copy, and then paste it here. Okay, so what else we need? We need benchmark. Okay, here we have a benchmark. Copy, paste it here, drop, and a 0. So here we have calculated beta. So we have calculated all this information. Now we need to calculate tracking error, then Sharpe ratio, Sortino ratio, Treynor, and information. Okay, so let me calculation of tracking error. Okay, so tracking error underscore I. So the good part is it's here. I can just copy all this information here till here and then paste it here. But here I need to subtract it. So instead of comma and something, I need to subtract because we know the formula of tracking error. It's a difference between, it's a volatility of the difference between stock return or fund return minus benchmark return. So all I need to do is I will put it in the bracket dot std into np dot sqrt 252. So we have analyzed tracking error as well. Okay, so what we need to calculate? We need to calculate Sharpe ratio. So Sharpe underscore I is equal to stock return minus risk-free rate divided by RF divided by 100. So we didn't define RF here. Divided by STT underscore I. Yeah, so we didn't define RF here. So all we need to do is we need to define RF here. Okay, so this is our Sharpe ratio. Okay, so calculation of Sortino ratio. So Sortino will be equal to stock return minus MAR divided by 100 divided by downside deviation. Again, we didn't define MAR, so this is minimum acceptable return. And then we need to calculate Treynor ratio. So Treynor of I is equal to stock return minus RF slash 100 slash beta. And the last one we have here is information ratio. So, okay. So information score I is equal to stock return minus benchmark return. I need to make sure that I have defined bench return. Okay, this is perfect. Divided by tracking error. Great. So let me just quickly explain what I have done here. So the same thing what I have done, I have downloaded the data. So I have downloaded, first I defined the data frame, then I download the data. In order to present it in a presentable form, I need to download one more library, which is beautiful table. And then by using this beautiful table, I will put the result in a proper presentable way. Okay, after that I run a loop and then I start doing calculation of daily return of stocks and benchmark, and then I calculate cumulative return, which is, you can say, the return over the period of time. And then I calculate standard deviation and downside deviation of a stock. Then I calculate beta. So there are so many ways to calculate beta, but this is one of the quickest ways. So that's why I'm using linear regression. Again, there are so many ways we can calculate it by using covariance matrix, calculation of tracking error. So I have calculated tracking error here. It's again analyze, calculation of Sharpe ratio. And then we have calculated Sortino ratio. We have calculated Treynor ratio and then information. Now let's start printing. So first I will just print it in a simple way. So it will be like return, just a sec. Okay. Stock return, comma, bench return, comma, beta. Then we have tracking error. Okay, so it will be TE. Then we have, okay, after return, we have a standard deviation, beta, tracking error, we have Sharpe, we have Sortino, we have Treynor, and we have information ratio. So let's run this. Okay. Let me just disable this line of code. And then what we have here, let me just RAPM, and then we need to pass the list. So right now I will just work on Apple just for the sake of running it, and then SNB GSPC. Then we have start date 1-1-2020. We have end date 12/31/2020. We have, let's assume, risk-free rate 2% and minimum acceptable return is also 2%. Let's run this and see. Okay, so adjusting, okay, I just write adjusting closing because I was saying we are going to use adjusting closing price, so it should be adjusting close. Okay, I need to disable this line as well. Okay. Okay, so we have got the result, but it's not very clear. It's not in a good readable form. So now what I'm going to do here, this is the time to use this beautiful table. So, okay, here, first thing I'm going to put a stock name. After that, I'm gonna put a return, and then I will put standard deviation. I will put downside deviation, beta, tracking error, Sharpe ratio, Sortino ratio, Treynor ratio, and then information ratio. Perfect. So we are going to uh, print these information. Let's do it. So we already have table.columns.header. So these are the header we are going to have for the table, and then table.style. This is something we can change, which I will show you in a while. And then we need to, let's say, since I have already printed this, so let's say I'm saying this name column is equal to, so we need to make sure that what information we are passing here, it should match with the column. So I, which is a stock, and then we need return. Return is here. We need benchmark return. Okay, we can put benchmark return as well. So let's say benchmark return. I think this table will be very big, I'm pretty sure. Okay, and then yeah, benchmark return, we have a standard deviation, and then after that we have downside deviation. So let me put downside deviation here, downside deviation. Then we have beta, we have tracking error, Sharpe, Sortino, Treynor, and information ratio. So let's, so this is something what we are doing. We are putting all this result in one variable called column. So we have assigned a variable called column. Now, what I'm going to do, I'm going to put all this data in individual rows. So table, which I have defined here. So this is the table I have already defined on top. Table is equal to beautiful table. So table dot rows dot append. So what will happen, whatever result we will have, we will add it in the table row wise, and it will be column. Perfect. And now I'm going to print table. So let me just get rid of this. Okay, let's run this now and see. Okay, nice. I think, okay, so it will be column dot header. Table dot header has no attribute column. Okay. Oh, it was right before, it was column. So let me just columns underscore headers. Let's run this again. The style box. Let's check here. What's the problem? Let me put it here and then see. Okay, basically table and then, okay. Uh, Let me check here. Table, beautiful table. Okay, let's run this. Okay, great. But here we need to do one thing. So it will not be like this. It will be columns dot headers. Oops. Okay, let me check. Columns dot header. And then let's do one thing. Let's put it on top. In fact, cut it and then paste it here. And then see how it works. Perfect. Okay. And then we can do one more thing. Since this style doesn't look good at all, we can check the style. Double box. See, again, it will be box. I don't want box. Let's check the compact. It's again not that good. Then let's see what else we have. Okay, I personally like this one. Let's see. Okay, we need to check for FB. We need to check the number for Amazon, and then let's run this. So we have the result here, but it's not in a good readable form. So all I need to do is I need to increase the size of this table. For that, all I need to do here is I need to increase the table size. So max width, let's say 200. We can just try and run this. Let's see. Okay, so Sortino ratio, then Treynor and information. So what I'm going to do, I will decrease the size. Let's say 100 and then see how it's look like. Okay, it's much better. And let's say we are going to make it 120 and then see how it goes. Okay, it's pretty much well. Perfect. So, okay, all I can do here is I will now do some changing. So round comma 2 plus percentage, and for that what I will do, I will put this under string. So let's see again. Nice, but before that I need to multiply it with 100. Great, so we have 78% return, 30% return, and 71% return. Similarly, I can do the same for benchmark. So all I need to do is I will just copy it and cut this from here and put it here. Beta will remain same, but I just want up to 2 decimal place. For information, it will be same as well. Let's run this and see. Okay. So and then great. So that's all for today. Hope you like this video, and hope it's more clear for you that how we can do all this calculation in one go by using a definition. So if you have any comments, if you have any query, just feel free to ask. If you want this code, please do let me know. I will share it with you. And if you have any comments, any suggestion, please do let me know as well. I will really appreciate it. If you like this video, please like and subscribe my channel. Thank you.